In this video, we will continue practicing solving trig equations like this one. We will also handle some trig equations that involve double angle identities like this one. And we will even do some that require all different kinds of factoring like these. But the first one is pretty straightforward. Well, I think this is supposed to be cosine squared x. Anyway, we need to add 1 and divide by 4. So that would give us cosine squared x is equal to 1 over 4. Then, of course, we need to take the square root of both sides. So that will give us cosine of x is equal to plus or minus. Don't forget the plus or minus. And you know what? I'm going to show an extra step that I normally don't show. The square root of 1/4, you need to understand that that is the same thing as the square root of 1 over the square root of 4. All right, which is why we're going to end up with plus or minus 1/2. So, the reference angle, what is the reference angle? Ignore the plus and minus. The cosine of what angle is 1/2? Now you long ago should have memorized this chart. So here's the cosine of pi over 3 is 1/2. That tells us that the reference angle is pi over 3. Now we think about what quadrant we're in. Well, since we want positive or negative, then that means we're going to wind up using every single quadrant, all 4 quadrants. All right, so this is what you should be picturing in your mind, but you shouldn't have to draw the picture. Here are a bunch of pi over 3's. Okay, 1 in each quadrant. These are the 4 angles that have a reference angle of pi over 3. Cosine is an x value, so it will be positive in the first and fourth quadrant. It will be negative in the second and third quadrant. But since we want plus or minus, we want them all. So x is going to equal pi over 3 itself, and 2 pi over 3, and this is 4 pi over 3, and 5 pi over 3. All right, so that's the solution to number 81. Number 82 just looks like a factoring problem. We're going to start by subtracting 3 from both sides, so that's going to be 2 cosine squared x plus 3 sine x minus 3 equals 0. Something that I didn't notice at first glance, these are not the same trig function. I have cosine and sine. So I do need to fix that. So I've got my cosine squared, and so I'm going to replace that with another expression. So a long time ago we had our Pythagorean identities. Maybe I'll just do this off to the side. The most important Pythagorean identity was this. Sine squared x plus cosine squared x is equal to 1. If I get cosine squared by itself by subtracting sine squared from both sides, that would give me cosine squared x is equal to 1 minus sine squared x. So this is a substitution that I can do. So instead of cosine squared, in parentheses, mind you, I can put 1 minus sine squared. So this will be the same thing as 2 times 1 minus sine squared, and then the rest of it. All right, a little distributive property with the 2 is going to give me 2 minus 2 sine squared x plus 3 sine x minus 3 is equal to 0. Noticing that the 2 and the negative 3 are like terms, I can put those together. So now I will have negative 2 sine squared x plus 3 sine x minus 1 is equal to 0. Now, I don't like having my leading coefficient be negative, so I'm just going to divide everything by negative 1. So that's going to give me positive 2 sine squared x minus 3 sine x plus 1 is equal to 0. So now it's time to do the factoring that I have been anticipating. So here we go with the factoring. Sine squared x will factor as 2 sine x times sine x. Then I skip over to the 1. 1 will only factor as 1 times 1. Inner plus outer must equal the middle. Inner, I have 1 sine x. Outer, I have 2 sine x, if I multiply these together. Together, these must equal negative 3 sine x. The only way that's going to happen is if they are both negative, which means that both of these have to be negative. Double check to make sure that negative 1 times negative 1 equals this positive 1. And it does, so that means we have factored correctly. So I'm just going to make a little space here. Now by the zero product property, I can set each one of these equal to 0. So 2 sine x minus 1 is equal to 0, and sine x minus 1 is equal to 0. Okay, getting x by its, getting sine x by itself, I'm adding 1 and dividing by 2, so sine x is equal to 1/2. Meanwhile, simply adding 1 to both sides, sine x is equal to 1. Okay, so now I start asking myself about reference angles and such. The sine of what angle is 1/2? Hopefully you've memorized that that is pi over 6. Okay, so that means pi over 6 is the reference angle. Okay, so just think pi over 6. I need a positive 1/2. Sine is positive in the first quadrant and in the second quadrant. Okay, so in the first quadrant, that's just plain old pi over 6. Okay, that's what this is. Now, in the second quadrant, if I went all the way to pi, that would be the same thing as 6 pi over 6. So this is 1 short, so that's going to be 5 pi over 6 right here. Okay, now, what about the sine of x equaling 1? Well, that's going to be a quadrantal angle. It's going to be one of these. Sine is a y value. The y value is 1 at the very top. So that's why we're going to add pi over 2 to the list. And that's it. These are the 3 solutions to this problem. Okay, and that was number 82. All right, this one is a little bit extra tricky. There's nothing squared in this problem. So I'm going to have to square both sides to get some identities that I can use and substitute for. However, when you square both sides of the equation like this, you can create fake answers, all right? You can create a situation where you're getting solutions that don't actually work. So bottom line, when you square both sides, you have to check your answers. That's the bottom line. So if I square this side, I really have to multiply sine x minus cosine x times sine x minus cosine x. All right, and this is going to equal 1. So to multiply these out, it's going to be like a double distributive property. So sine times sine, that's going to be sine squared x. Sine times negative cosine is negative sine cosine. Now I'm going to distribute the cosine. So negative cosine times sine is negative sine cosine. And negative cosine times negative cosine is positive cosine squared. So you probably noticed that we have like terms right here in the middle. All right, these two are like terms. So if we put those together, that'll make negative 2 sine x cosine x. So now I'm going to have sine squared x minus 2 sine x cosine x, okay, plus cosine squared x is equal to 1. Now, I'm noticing that we have sine squared plus cosine squared. Right? I could easily just rearrange this, couldn't I? I could rearrange this so I would have sine squared plus cosine squared minus 2 sine cosine is equal to 1. I just rearranged the order so that the sine squared and the cosine squared would be next to each other. Because now hopefully you recognize and remember that this is the number 1 Pythagorean identity. So you should have memorized that the value of this is 1. All right, this came up on the previous problem. Sine squared plus cosine squared equals 1. So I'm going to just replace all this with the number 1. So now I have 1 minus 2 sine x cosine x is equal to 1. Now if I subtract 1 from both sides, that's going to give me negative 2 sine x cosine x is equal to 0. All right, so this is great. So now I can use my zero product property and just set these two factors equal to 0. I'm sort of drawing a line right here. So I could just set negative 2 sine x equal to 0, and I can set cosine x equal to 0. If I divide both sides by negative 2, this just gives me sine x is equal to 0. So these are all quadrantal angles that we're talking about. All right, so let's list it out. X equals. Sine is a y value. The y values are 0 here and here. So that we'll call that 0 and pi. Cosine is an x value. The x values are 0 here and here. So that's going to be pi over 2 and 3 pi over 2. So wait, so these are the solutions, except because we squared both sides, we have to check these. So I'm going to unbox these until we check them. All right, so we really have to check them one by one, which I will do over here. Okay, so let's start by checking x equals 0 and see how that works out. Okay, so we have, and I'm just going to write this right here. So I have sine x minus cosine x equals 1. This was the original equation. If x is 0, then that means I have sine 0 minus cosine 0 is equal to 1. Sine of 0 is 0, all right, because at 0, the y value is 0. Cosine of 0 is 1. Okay, because cosine is the x value, and the x value is 1 right here. So the question is this a true statement? No, because this is telling me that negative 1 is equal to positive 1. So these are not equal. So that means x equals 0 is not a true solution. So I have to throw that out. That's called extraneous. So now I'm going to check pi. Okay, I'm going to check x equals pi. So this would be sine pi minus cosine pi is equal to 1. Okay, so pi is over here on the left-hand side. So sine of pi is 0. Cosine of pi is negative 1. So the question is, does this all equal positive 1? Well, minus a negative is addition. So it does become positive 1 equals positive 1. So this checks out. Okay, so pi is a good solution. All right, next we're going to check pi over 2. Okay, so that's going to make sine of pi over 2 minus cosine of pi over 2. That must equal 1. Pi over 2 is up here at the top, where sine is 1 and cosine is 0. So that's 1 minus 0. All right, and that does check out. So pi over 2 is a good solution. Okay, now finally, what about 3 pi over 2? So that would be the sine of 3 pi over 2 minus the cosine of 3 pi over 2. And we have to see if that equals 1. So, of course, 3 pi over 2 is right here, where sine is negative 1 and cosine is 0. Okay, so sine is negative 1 and cosine is 0. Well, this would just boil down to negative 1 equals 1. And of course these are not equal, which means none of these are equal. All right, so this does not check out. So that is another extraneous solution. So in the end, x equals pi and pi over 2. These are the only true solutions. Okay, this one, I see we have cotangent in here. I don't like having 3 different trig functions, so I'm going to go ahead and write cotangent in terms of sine and cosine. So that's going to give me cosine squared x is equal to, and cotangent would be cosine over sine. Okay, and then I've still got this extra sine x hanging around. So these are going to cancel each other out. So that's going to leave me with cosine squared x is equal to cosine x. It might be tempting to divide both sides by cosine, but then you remember that you cannot divide by a trig function because the trig functions are often 0. Instead, we subtract and take out a GCF. So cosine squared x minus cosine x is equal to 0. Now we will take out a GCF of cosine x. So cosine x times cosine x minus 1. Now, using the 0 product property, we can set each of these equal to 0. So cosine x equals 0 and cosine x minus 1 equals 0. Here, adding 1 to both sides, I get cosine x is equal to 1. So quadrantal angles, once again, let's see, you don't want to get in the way of the next problem. So just picture these in your mind. Cosine, where is cosine going to be 0? Cosine is an x value. X values are 0 here and here. So far that gives me x is equal to pi over 2 and 3 pi over 2. Now, in addition, I need to know where cosine is equal to 1. Well, x values are 1 over here to the right, and that is at 0. So these are the 3 solutions. So that one was relatively straightforward. Let's do one more. This last one has the double angle in it, so watch out. Sine of 2x is 2 sine cosine. So let's do that right away. So we're going to have 2 sine x cosine x, okay? And then we have this extra cosine, and that's equal to sine x. Since we can't divide both sides by sine, we're going to subtract it. But first of all, we might as well put this together as cosine squared. So I have 2 sine x cosine squared x. Now I'm subtracting the sine, so minus sine x is equal to 0. Now sine x is a common factor, so we will take out the GCF of sine x, and that's going to leave behind 2 cosine squared x minus 1. So using the zero product property, I will set each one of these equal to 0. Okay, now working this 1 on the right, I'm going to add 1 and divide by 2. So that's going to give me cosine squared x is equal to 1/2. Now I need to take the square root of both sides. So that's going to give me cosine of x is equal to, please don't forget your plus or minus, 1 over radical 2. Okay, so now it's time to solve each one of these the rest of the way. So sine x equals 0, we are talking about quadrantal angles. So sine is a y value. Y values are 0 here and here. So that's going to be 0 and pi. Now, for cosine equals plus or minus 1 over radical 2, let's start by talking about what the reference angle is. The cosine of what is 1 over radical 2? That's pi over 4. All right? Again, that's one of these ones that we've memorized. The cosine of pi over 4 is 1 over radical 2. Okay, so you should be able to name the angles that we need without drawing this picture. I'm just drawing this picture because you can't read my mind, and I need to show you what I'm thinking. Okay, these are all of the angles that have a reference angle of pi over 4. Since we want of the positive version and the negative versions, we're going to take all 4 quadrants. So the first one is simply pi over 4 itself. And then the second one is 3 pi over 4. And then the next one is 5 pi over 4. And then the last one is 7 pi over 4. Okay, so all of these are solutions, and we'll keep them all. So that was it for number 85. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video, click in the green apple to subscribe, or click the yellow apple for the full playlist.